Good morning. I'm going to talk a bit about lift on an airfoil, more precisely how it is generated or how it is caused in airplane wings. The reason I'm keeping this video in the beginning is because lift is often explained wrongly, generally by aviators who don't know or are not supposed to know physics. Like this one, you have probably heard of an explanation like this. So this be an airfoil, okay? And they'll tell you that the air above covers a larger distance than the air below, and that air molecules separating here should meet here. So the molecules above need to cover a larger distance in order to meet, and hence the velocity, or rather the speed, should be higher than the ones below, and thus higher speed means a lower pressure, and a lower speed means higher pressure, and thus you get lift. Now this is wrong, because anybody would understand, because you see the doubt is very prominent. The molecules just don't meet. Why would they meet? Why do they need to meet? That's the most prominent doubt anybody would have, and that doubt is right. They don't need to meet. So gone. This theory is just wrong. So in order to actually explain lift, I'd like you guys to remember something that you've probably seen before. Let this be a tap. And let this be a stream of water, and here you have a cylinder. Now if you hold this cylinder into the stream, you see that the stream goes like this and then does not fall straight. It just does this and then falls straight. Similarly here, it does this and then falls straight. Why? This effect is called the Quanda effect. Sorry, I'm just a little sick today. Sorry, just excuse me. So anyway, this effect is called Quanda effect, and Quanda is this C-O-A-N-D-A, Quanda effect, E-F-F-E-C-T. Now this same Quanda effect applies on airfoil too. So you have an airfoil. I'm drawing a curved airfoil because it will help you understand better. So you have probably imagined this, the circulation of air outside an airfoil, but I'm still going to show it is like this and this. Look how it touches the surface. Quanda effect is just the liquid or the fluid touches the convex surface. It does not separate from the surface. So here it touches the surface, and in this figure, let us take a cube of air above the airfoil and below the airfoil. Let's draw this. Let's enlarge this. it moves in a curved path, right? So there must be a centripetal force acting this way. What does this mean? It means it has a pressure above it greater than the pressure below it. Right? So this air cube is pretty much being pushed this way. F net acts this way, and below is the same. F net acts downwards. Now. Somewhere over here, the pressure is PADM, atmospheric pressure, and somewhere over here, the pressure is also PADM, atmospheric pressure. That I am neglecting the difference. So there will be a difference due to height and atmospheric conditions, but I'm just neglecting that at the moment. And so the pressure right above the airfoil is going to be higher than PADM, and the pressure right below the airfoil is going to be below PADM, right? This tells us that this and this. So you have a pressure right above the airfoil below PADM and right below above PADM. That creates a pressure difference, and this difference pushes the airfoil. Now this is basically the cause behind lift in an airfoil, and you can actually understand this better if you take examples of, say, when the Wright brothers flew their first aircraft, their wings were not really airfoils. They were basically just bent wooden planks. How did those generate lift? The same way. Airstream, pressure. Remember this sentence. Curvature of air causes lift. And this is very important. This sentence will explain basically everything from sailboats to planes to Wright brothers aircraft, everything. So yeah, that's it for today. You people might see that symmetric airfoils, people might have noticed this, that symmetric airfoils do not cause lift, right? If you have ever made an RC plane or an RC aircraft or something, you would have probably come across this and would have troubled. In order to generate lift, these airfoils need to be at an angle with the horizontal. So the airflow should be like this. This produces lift, right? Voila, there you go. In fact, today's airplanes, in airliners, if you notice, the wings are kind of convex, like this. Why? Because that's for a different video, but I'm just going to tell you. It's because they reduce drag at high speeds. So in order to actually generate a high amount of lift, what they do is they use flaps. You probably know, but I'm just saying this. They use flaps as well as slats to make the curvature like this, and there you go, you have lift. So that's it for today. I know my video is very unprofessional and very I don't know how to describe it, but it's a hodgepodge basically. But well, it's still something. I mean, I believe the content matters, and I'm coming up with new videos, so stay tuned. Thank you.